In this short video, we're going to look at stratified samples and random samples. Now, quite often in GCSE, you're asked to describe what a random sample is. So, a random sample is a subset or a part of a group. So, part is a number of people, part of a group. So a number of ways you can describe it. Part of a group where the selection of the sample makes sure each person or each member of the group, each member has an equal chance. And this is the key word, an equal chance of being in the group. And suppose you were choosing, 10 students from 100, and you might put 100 names on 100 separate pieces of paper, put them into a bag, and then select them out, shuffling the bag. So each, there's no one bit of paper that had more chance of coming out than another, and that meant that every person then has an equal chance of being selected. Now, stratified samples are samples at GCSE. You have to understand the following concept, where there's subsets of a group. So I've got this table to help you understand this. I've got this table here, and it's got Year 7, Year 8 and Year 9 students, and we've got 60 boys in Year 7 and 80 girls, which gives us a total of 140. And you've got similar information for Year 8 and Year 9. So the principle of a stratified sample, again, it's a smaller subset of the main group, but the rule about it being stratified is that each subgroup must be represented proportionally. So, for example, in a very simple case, suppose you had 100 boys and 100 girls, and you wanted 20 in the sample, then you'd have 10 boys and 10 girls, because there's half of the main group are boys and half of the main group are girls, so that's got to be exactly the same in the sample. That's very simple in a simple example like that, but in a table, it's a bit more difficult. So I'm going to show you how to handle it. So we've got 50 students in the sample, so how many Year 8s should I have? So it will be 50 times the proportion of Year 8s in the whole group. And the number of Year 8s is 140, and the number of the whole population of the group is 370. Now I'm not really going to be able to do that on my calculator. Sorry, I am going to be able to do it on my calculator, should I say. And not in my head, so we'll just get the calculator up and do that. And there's an important bit to show you at the end when I've worked this out. So 50 times 140 divided by 370 equals, so there we've got 18.91 or 18.92. Now we can't leave that as the answer because you cannot have 18.92 students, so you must round up. So the answer we'll give will be 19 Year 8s. Now the total number of boys in the sample, well again it's 50 times the proportion of boys in the sample. If you come down this column, you'll see that there's 170 male from 370. So 170 from 370. Again, we use our calculator to work that out. 50 times 170 divided by 370. I get 22.97, which we write as 23. Okay, and one final example then. How many Year 9 girls in the sample? Okay, it's 50 is the sample size. So if we look for the Year 9 girls, there are 50 of them out of the 370 in the total. So times 50 over 370. So if we do that, 50 times 50 divided by 370, and we get 6.76, and that will be 7. We must, in every case, round to a whole number, because we obviously can't have fractions of girls. So that's how to calculate the proportion of students from different subgroups in a stratified sample, and hopefully also you understand that a random sample is one where you take a smaller group from the population, and each member of that group must have an equal chance of being selected. I hope that helps.